Start recording. There we go. Okay. So for our organic acids, they are all going to end in COOH, which means the anion for them is COO, and they're all on the third page of that data sheet. So if we go back here, normally, when we write ions, do we write the positive ion first or do we write the negative ion first? Normally, you have no idea. Sodium chloride, which one comes first, positive or negative? Positive. Everyone, all of them, positive comes before negative. But for organic acids, it's backwards, okay? It's because of their structure and how we write it to show their structure, okay? And we'll talk about why a little bit just after we've gone through how, okay? But for organic acids, it's the negative than the positive. And the positive in this case will be the hydrogen ion, okay? So we might have CH3COO, and then we have our H. Okay, so our negative ion goes first, the CH3COO minus, and then that right there is the H plus. Okay, now the name of CH3COO, you can go look that one up. That's the only one of the organic acids that is actually on just the very front page of the polyatomic ion sheet. So you could look up acetate there. It's also known as ethanoate. But you can also look on the organic acids and you can say, CH3COO minus is acetate. So the name is acetate. And remember, I ate something icky. I don't know if something is two words there. So what we do is we take the 8 and we replace it with the ick. So it becomes acetate, becomes acetic acid. Yes? Okay. And it's going to be the same for all of the other ones. So you would look up HCOO minus and you'd say, HCOO minus is either formate or methanoate. All right. I'm going to go with formate because it's shorter. I always like shorter. Okay. So that would be formate. We replace the 8 with ick and it becomes formic acid. Okay. Benzoate becomes benzoic acid. Propanoate becomes propanoic acid. So we just take off the 8 and put the ick on the end. That one's long, propano. Yes? Now, if you're interested in knowing why the hydrogen goes at the end, we're going to look at that. You don't have to know this. You don't have to understand it. So if you look at this and you're like, that's just too complicated for me, I don't care, you don't need to care this year. Okay? So here is ethanoic acid. And this hydrogen right here is the H plus. Okay, there's a whole bunch of hydrogens in there. But that one right there is the H+. These hydrogens are not acidic, okay? They are bonded covalently to the carbon, and they don't like come off in solution. Do you remember what happens when we take NaCl and we dissolve it in water? What happens to the ions? Yes. They separate. Yes? The ions separate. So you end up with Na plus separate from Cl minus. That process, does anyone remember what that process is called? Dissociation. So when an acid dissolves in water, it separates, it dissociates into H+, and whatever the anion is, okay? And when this guy dissociates, it is this hydrogen that actually comes off and becomes H+, all right? And so you can see the structure here. We have the COOH. We have COOH. And we usually write that on the right-hand side of the structural formula. That's what this type of formula is called, the structural formula. And yeah, that's it. So if you're interested, that's why we write the H at the end. But otherwise, you just have to know that for those ones we do. Now, actually, never mind it. So that's going to come up later. Okay, and don't forget, what were our other mnemonic devices we had? I ate something icky. What were the other two? My Sprite is delicious. So when we had 8, we replaced the 8 with ick. If we have an ite ion, so let's say we had HClO2. ClO2 is chlorite. We take away the ite and we add us. Okay, so we take away the ite and we add us. So chlorite becomes chlorus acid. HClO, that comes from the ClO minus ion. That is named hypochlorite. So you take away the ite and you're left with the hypochlor. And then what do? You stick an us on the end. Hypochlorous acid. Okay? So those are 2 of the rules. I ate something icky. My Sprite is delicious. And there is a third one. What is the third rule? My ride, because we have ide ions too, like chloride, phosphide, cyanide. My ride has hydraulics. So you need to put hydro on the front and ick on the end. So let's say we had phosphide. That's the P3 minus ion. How would we write the acid name for H3P? Well, we need to have an ick. Ooh, I shouldn't have picked phosphide because it's got the little weird extra thing. Let's do something different. Let's just do chlorine. No, let's do fluoride, fluoride, fluoride. There we go. F minus. That would be hydrofluoric acid, because that is from the fluoride ion. So when the ion ends in ide, we put a hydro on the front and an ic on the end, and then we write acid. Okay? Also, don't forget, there's two elements whose names are a little bit funny when we do them with acids. What are those two elements? Phosphorus and sulfur, salt and pepper, S and P. Okay? S and P need what? Extra syllable. The S needs an and the P needs an or. Okay, so here's an example where we have this guy here. This is SO3 minus. Now that is the sulfite ion, and normally you'd be like, okay, I have ite. Let's just replace the ite with us, and we'd get sulfus acid. But we need sulfurous acid, so we have to put that extra UR in there. Okay? Sulfurous acid. Yeah? Same thing with, like, let's say we had, let's do now H3P. What's the name of the P ion? P3 minus is phosphide. Okay, and so we would, now it's an ide, so my ride has hydraulics. So I need to call this hydro. Now, normally I would just say phosphic, but because it's phosphorus, I need an extra or. So instead of just phosphic, it's going to be hydrophosphoric acid. Okay? So that is just a quick review of naming acids, and now we're going to go to page 79. Do which one? Oh, yeah.
Was mine this?
Yes. Yes. There might be a better one. Okay, page 79. So every time we have an acid, so anytime you actually see the word acid, you can say, I have a hydrogen ion, H+. Okay? Now let's say that let's say I gave you sodium sulfate. How would you write the formula for that? Sodium sulfate. What would you have to do? This is not an acid. This one has nothing to do with acids. This is an ionic compound. Yeah, how would I write the formula for that? I need an Na. And in order to write the correct formula, I would also need to know that Na is plus. Yes? What else would I need to know? I would need to know sulfate, which is SO4. Not sulfide, sulfate. And so I would say, sulfate is SO4 and its charge is 2-. that would mean that I would need to have 2 NAs to balance out that 2 negative charge, which would give us Na2SO4. Acid formulas, we do them exactly the same way. The only thing that's different is that you have to realize that the positive ion is hydrogen, okay? So let's say we had, once again, my ride has hydraulics. So if I have hydroic with a brome in the middle, what is the ion? Is it a bromide, a bromite, or a bromate? My ride has hydraulics. So you're like, okay, that must be bromide because I've got the hydroic. Yes? Bromide is Br minus. I know that my positive ion is H plus. So the formula for that is going to be HBr. Hydrosulfuric. Again, it's got that hydroic, so that is going to be the sulfide ion. And you can look on your periodic table and you can say sulfur is here in group 16, which means it has a -2 charge. So I have S2 minus, which goes with my H plus. And that means that I need to have 2 hydrogens to balance out the 2 minus. So our formula is going to be H2S. Is good? Okay. We're going to just skip the last couple because we want to just keep moving, but you can feel free to read through them and take a look through them. Okay. And now we have the ick acids. This is I ate something icky. So I have bromic acid. There's no hydro, so it's not an ide ion. It's just ick, so it's an 8 ion. So I'm going to take my brome. And it's going to be 8, bromate. Okay, so the ick becomes 8. Now, here's where you want to look. You want to go to your data sheet and probably, let's take a look here. We have anions. We have a choice. Here they are arranged by charge. On the previous page, they are arranged by alphabet. So bromate is under B, and that is BrO3 minus. So that's a nice place to find it, okay? So we have BrO3 minus, and it's an acid, so our other ion is H plus, which means that it's going to be HBrO3. Yes? Okay. Sulfuric, that's going to be what's the ending? If it's a sulfuric acid, what ion are we dealing with? Sulf 8. I ate something icky. Okay, so that's SO4, 2 minus. And then, of course, it pairs off with who? Hydrogen, H plus. And so we need 2 H's to balance the SO4, 2 minus. Okay. We're going to skip those and we're going to move on to organic acids. Remember, organic acids are a little bit funny. Look out for the COO. Where does the H go? The H goes on the end. Yeah, the H goes on the right. So let's take a look at the name methanoic acid. And you're like, what the heck is methanoic acid? Well, hopefully it will be on my anions for acids sheet. Okay, so I can go to my data sheet. And I can go under M. There's M, methanoate. Is everyone finding this on their sheet? Because this might be harder for you to find. Okay, so methanoate, go look for it. Page 2 has them alphabetically, page 3 has them by charge. Okay, so this is where alphabetical might come in handy, right? Because you've got M, methanoate is HCOO minus. So we have HCOO minus is methanoate, and we need to put it with H plus. Now we look at this and we say, I have the COO, and that means the hydrogen goes on the end. So we're going to have HCOOH. I know it's crazy. But you know what looks even crazier? HHCOO. Does that not look weird? No. What?
Yeah, from my grade 10.
Oh, anyway, looks crazy. I would probably give you a half a mark if you did that. Because it's not, I mean, that one, especially this one is really ugly. Okay. Ethanoic acid, ethanoate. So we go and we look up F on our data sheet. Under E, ethanoate CH3COO minus. Okay, that goes together with H plus. So if you write CH3COOH, I'll give you full marks. If you write HCH3COO, I will give you half marks because you're in grade 11 now. Okay? So those are our ick acids. Last but not least, we've done our hydroics, we've done our icks. What's the last kind? Hydroic, ick, and us. So let's take a look at our us. Bromous acid. My Sprite is delicious. So for our us, that's going to be brome. What's the ending? What's the ion ending? Ite, bromite. And you're like, okay, I don't know what bromite is. Go back, look at my data sheet, bromite. Under B, oh, we got bromate, bromide, bromite. BrO2 minus. Okay, and that's going to go with H. And so that's going to become HBrO2. Okay, you now have all, in theory, you have all the knowledge to do quizzes 9 and 10, but you'll want to do some practice first, yes? So if you have not yet written quiz 6, you'll be writing quiz 6 now. Otherwise, you're working on pages 77, 78, 81, and 82. And if you feel ready to write quiz 9 and 10 today, you can do that. If you don't, you can write them tomorrow. Be ready to write them tomorrow. Okay?
Can we do C start zone?
You can do quiz 6 right now. Yes.
So